question number 2. This one contains some different stuff. Okay, so it says carbon dioxide and solid calcium oxide are produced when solid calcium carbonate absorbs 177.8 kilojoules of energy. Complete and balance the chemical equation below. Remember to include heat. Again, we were lucky. This has already been balanced for us as far as the equation goes. It does satisfy the law of conservation of matter. Now we need to satisfy the law of conservation of energy and show the production or absorption of energy. So I'm going to take a look at my word problem and see if there's any context clues that give me a hint as far as, is this absorbed? Is this released? Endothermic, exothermic? And here I see absorbs 177.8 kilojoules, which is awesome. So if it absorbs 177.8 kilojoules, that means it's required as a part of the reaction to take place. So we need it as one of our ingredients. It's being added into the chemical equation. And so this would in fact be a reactant. So this is an endothermic reaction, and so heat is treated as a reactant. If you would like to write it the way I like to write it as a footnote, this is how it would look. Because we are absorbing that energy, heat is entering the system, therefore the delta H value should be positive. So let's go ahead and remind ourselves too that this reads as 177.8 kilojoules of energy per 1 mole of substance are absorbed. So they're saying here in this, if I want to decompose 1 mole of calcium carbonate, I need 177.8 kilojoules of energy. If I have 3 moles of calcium carbonate, I'm going to need 3 times the amount of energy to break down all 3 moles of that calcium carbonate, okay? So that's our relationship, that's our conversion factor, that's why it's kilojoules per mole. Okay, so let's do some calculations with this. Calculate how many moles of calcium oxide is produced when 345 kilojoules of heat energy is gained. So again, I like to look at kind of my context clues. What am I starting with? Where am I going? I know that this is a conversion factor, but I don't know what I'm doing. So it's asking me for moles of calcium oxide, and it's giving me heat energy. So I'm going to rewrite my chemical equation, and I'm going to start with what I know. That's 345 kilojoules. So 345 kilojoules is going to be over unitless 1, just so we have our numerators and denominators lined up. We know we're going to be adding this into a chemical equation. Let me get we're going to be adding a conversion factor of some sort, but we need to decide which conversion factor. We've got 4 to choose from, and if we're starting with kilojoules here, we have kilojoules on top, that means we need to have kilojoules on the bottom. So which conversion factor am I going to use? Well, there's only one conversion factor that has kilojoules in it, and it's this bottom right one. So we are going to put kilojoules on the bottom. Remember, this number of kilojoules of heat energy, that comes directly from your balanced thermochemical equation. So we have 177.8 kilojoules per mole of, and in this case, we're trying to get to calcium oxide. So I want moles of calcium oxide on top, and I'm going to use the number that's in front, or the coefficient of calcium oxide from the equation. Oh, my arrows are a little bit out of order there. So now I have this set up. I'm getting rid of kilojoules. I am ending with calcium oxide, and I know that because kilojoules on top cancels with kilojoules on the bottom, and there is nothing canceling out moles of CaO. Go ahead and multiply my numerators together and my denominators together, and I end up with something that looks a little like this. Divide your top and bottom. We end up with 1.94038, or we round that to sig figs 1.94 moles of calcium oxide. Now, folks, if you have a negative number here, it's not possible to have a negative number of moles, right? That doesn't make sense. You can't have negative 12 rulers. Like, that doesn't work. You can't have a negative amount of something. So just pay attention to your signs. If you end up with a negative number for moles, you know you've done something wrong. All right, so let's take a look at number 2C. Calculate how much heat energy in kilojoules is absorbed when 3.40 grams of calcium carbonate decomposes. Okay, again, let's take a look at what it's asking. It's asking for how much heat energy in kilojoules is absorbed. Now, I highlighted all of that because it tells me a little bit of something about my answer. It's asking me for heat energy, and it's asking heat energy absorbed. So we already knew that this was an endothermic reaction, but now this is just like a second reminder. Okay, Jamie, all of my answers, my answer at the very end, it needs to be positive because this is heat energy, and we know that this is endothermic, and so heat energy is being absorbed, and so my final answer should be positive. Keep that in mind. If it's not positive, you did something wrong, okay? When 3.40 grams of calcium carbonate decomposes. Okay, great. I'm going to rewrite my thermochemical equation, and I'm going to start with what I know. 3.40 grams of calcium carbonate. I'm going to put that over a unitless one, and I know that I'm going to be multiplying it by some sort of conversion factor. Okay, so let's take a look at our conversion factors. We've got 4 to choose from. Which one am I going to use? Well, I'm starting with grams, so we need to pick something that has grams in it. It has moles and particles. Not going to help us. This has moles and kilojoules. I mean, we want to get to kilojoules, but this doesn't have grams, so we can't do anything with that. This has moles and moles. That doesn't help us. And then this has moles and grams. So we do want to use this one on the upper left-hand corner. And we know that grams of calcium carbonate needs to go on the bottom. So in order for us to calculate what number is supposed to go there, that number sign, remember, is going to be the molar masses, or the molar mass of calcium carbonate. So you have to look at your periodic table for this. That's 40.8 grams per mole plus 12.01 grams per mole plus 16 times 3 grams per mole. And the reason why I multiplied that 16 by 3 is because there are 3 oxygens in this equation, or in this formula. So I need to account for 3 masses of oxygen. So my total molar mass for calcium carbonate is 100.09 grams. If I use 1/2 of my conversion factor, I need to use the other half of my conversion factor, which is 1 mole of calcium carbonate, because X and X, they have to match. We're going to go ahead and multiply, or see where we're at right now. So we know that grams on top cancel grams on the bottom, and now we're left with moles of calcium carbonate, which is not what we're looking for, but we are one step closer. So we have now moles, so ignore the first half of this equation. Now let's focus on getting rid of this unit here. So I know that I have another conversion factor that I need to set up because I'm not quite to kilojoules yet. And I know that moles of calcium carbonate needs to go on the bottom because moles of calcium carbonate cancels with moles of calcium carbonate. So let's go ahead and find a conversion factor here that has moles of calcium carbonate, or moles, that's going to help us. Unfortunately, all 4 of these have moles in them. So how do we decide which one we pick? Well, this one takes us from moles of X, calcium carbonate, to moles of Y, which could be CO2 or CaO, and that's not what we're looking for, so we don't want that. Moles of X to grams of X, so that would take us to grams of CaCO3, which actually would undo the work we just did, so let's not do this one. This one would take us from moles of calcium carbonate to particles of calcium carbonate, or molecules of calcium carbonate, but that's not where we're going. So we're going to be using the bottom right-hand corner, this one here. We're going from moles of calcium carbonate to kilojoules of heat energy. So this number is going to be coming from the balanced thermochemical equation, so that should have a 1. And then if I use 1/2 of the conversion factor, I have to use the other half of the conversion factor. So kilojoules of heat energy goes on top, and that comes from our balanced thermochemical equation. Notice that it is a positive value, therefore it should be positive in your calculation. So now I know that I've correctly set this up because grams of calcium carbonate on top cancels with grams of calcium carbonate on the bottom. Moles of calcium carbonate on top cancels with moles of calcium carbonate on the bottom, and then we will be left with kilojoules. Let's multiply our numerators together, multiply our denominators together, and this is the new fraction that we get. Divide the top and bottom. We end up with 6.039764 rounded to 3 sig figs gives us 6.04 kilojoules of heat energy absorbed. And notice that it is a positive number. This does reflect an endothermic reaction, so we know that we've done this correctly.